Okay, Assalamualaikum warahmatullahi wabarakatuh. FCC dan BCC adalah satu nama dan juga satu term perbezaan untuk membezakan dua susunan crystalline structure. So maknanya FCC ni adalah face center cubic dan BCC adalah body center cubic. Okay, saya akan bahaskan untuk FCC. FCC jika dapat dilihat, ia adalah susunan di mana zarah-zarah sfera disusun dalam keadaan menghadap pada susunan zarah. Jika dapat dilihat di sini, muka setiap zarah akan menghadap kepada setiap kubik. Satu kubik ini akan mengandungi empat zarah. Maknanya ada 4 sfera. Okay, kenapa dia ada 4 adalah di atas adalah separuh hemisfer dan bawah adalah separuh. So bila digabungkan akan jadi satu sfera, dan pada bahagian depan dengan belakang jadi 2 sfera, bahagian tepi dengan sebelah belakang akan ada 3 sfera, dan setiap bucu ni jika digabungkan akan menjadi 4 sfera. So perbezaan antara BCC dan FCC, FCC mempunyai 4 sfera dan BCC mempunyai 2 sfera. Dan BCC adalah body center cubic di mana zarah utama berada pada keadaan tengah. So maknanya zarah bertutup likup, maknanya zarah yang sempurna berada pada keadaan tengah. Okay, perbezaan yang ketara pada keadaan BCC dan FCC adalah coordination number, di mana FCC mempunyai 12 structure, dan di mana BCC mempunyai 8 struktur structure. Okay, dan seterusnya adalah packing factor. Packing factor untuk FCC adalah 0.74. Kenapa 0.74? Adalah 74% daripada kubik FCC dilitupi oleh sfera itu sendiri. And then untuk BCC hanya 0.68, di mana 68% sahaja litupan kubik itu dengan sfera itu sendiri. So maknanya FCC mempunyai ruang letupan yang paling tinggi kerana permukaan muka menghadap kepada kubik lebih besar. Dan contoh kepada FCC adalah aluminium, kupron, emas, plumbum dan juga nikel. Dan untuk BCC adalah lithium, sodium, potasium, kromium dan juga barium. Ini adalah contoh-contoh crystal structure untuk FCC, dan ni adalah contoh crystal structure untuk BCC. And then ini adalah susunan untuk FCC jika kubik ini digabungkan menjadi satu bentuk metal yang sempurna. Okay, jika dapat dilihat, sfera utama berada pada keadaan luar. Dan untuk BCC, jika dapat dilihat, sfera utama berada pada keadaan tengah dan ditupi oleh sfera pada keadaan luar.
Okay, Assalamualaikum and hi. My name is HAFIZUL ILMI bin BHARURAJI. So today I'm gonna explain about the body centered cubic BCC crystal structure. Okay, let's go. Okay, so as we can see, in the picture, that is the cubic of crystal structure of body center. Okay, BCC is the most simple atomic structure and it is the most common way of atom arrangement. So as we can see, it has only about 9 atoms at the cube, and the yellow color circle representing the atom. Okay, there is about an atom on each corner of on the cube, and there is also an atom at the center of the cube. Each atom on the cube corner are sharing with the atom at the center of the cube. So basically, the crystal structure for BCC has the coordinate of 8, which means they have 8 atoms at the corner. And for BCC, it has 2 atoms per unit cell. So the center one, the atom at the center representing 1 atom, and the others 8 are representing another one. Okay, so the volume of BCC, the atoms are representing 68% of the cube volume, and the other 32% are the free space. Okay, the example of atom that has a BCC crystal structure is chromium, tungsten, and iron. So the atom arrangement in the BCC is not packed and closely as the other crystal structure or other arrangement, which is BCC and HCP. So in this BCC arrangement, the atoms are more difficult to slip to pass each other. Okay, that's all for the crystal structure of BCC.
In this part, I will presenting about the crystal structure of hexagonal flow spec, which is HCP. So HCP is one of the most stable crystal structures and the highest packing density. As we can see in the figure, HCP is a hexagonal prism with an atom on each vertex and 3 atoms in the center. Next, HCP has 6 atoms per unit cell and the coordination number is 12. And for the atomic packing factor, which is FPF, is 0.74. So that is exactly the same value as per center cubic, which is FCC crystal, because both HCP and FCC are close packed structures with the maximum possible of FPF. For the C per A ratio, which is 1.633, so the HCP cell is defined by 2 lattice constants, as we can see in this figure, which is A and C, which correspond to 2 side lengths in the primitive cell. For example of HCP is cadmium, magnesium, titanium, and zinc have an HCP structure at standard temperature and pressure.
Okay, so next I will explain about the mechanical properties different between BCC, FCC, and HCP. So BCC material is basically less ductile, which means has the lower degree to plastic deformation. Then BCC also less malleable, which is it cannot accept the larger stress or being hammered without cracking or breaking. Then, but the good of BCC, it is hard, which is basically the material that is hard is usually used to make a tool or cutting tool, with like drill or drill bit, tool bit. Okay, then we go to the another point, which is good strength. But the good strength of BCC depend on the length of the bond. The shorter the bond of the atom, the greater the strength of BCC material. Okay, next we are going to FCC, face-centered cubic. For face-centered cubic, it has higher ductility than BCC. It also has a good strength and a good toughness. And the atom of FCC is more stable at higher temperature. Besides, the atom also has the higher density and other crystal structure. Okay, then we are going to mechanical properties of HCP. So HCP is less ductile compared to FCC, but it is still greater than DCC. And HCP material also brittle fracture, which means it has highest possibility to crack or breaking. But HCP material has the best solid lubricant, which means the material of with HCP crystal structure has the lowest friction during sliding or during friction. Okay, that's all for the mechanical properties different for BCC, FCC, and HCP. Thank you.
Next, this is the interstitial sites. Interstitial sites are the places in the unit cell between atoms. In this figure, this is the two main types of interstitial sites are octahedral and tetrahedral in FCC and BCC. FCC and BCC crystal structures also have different arrangement of interstitial sites. As we're referring to the figure, octahedral sites in both FCC and BCC have an interstitial sites, which is referring to the purple circle, is among neighboring of 6 host atoms, which is referring to the yellow circle. For the tetrahedral site in FCC and BCC, it has an interstitial sites is among neighboring of 4 host atoms. Next, this is the interstitial site radius, which is R in BCC, FCC, and HCP. For the octahedral interstitial site radius for BCC is 0.155 R, which is R referring to a radius of an atom. And for octahedral interstitial site radius for FCC and HCP is 0.414 R. So this shows that the octahedral interstitial site radius for FCC and HCP is more bigger than BCC. Next, the tetrahedral interstitial site radius for BCC is 0.291 R, and both FCC and HCP is 0.225 R. And this shows that the tetrahedral interstitial sites radius for BCC is more bigger than FCC and HCP. For the cubic interstitial site radius is none, because interstitial site radius in BCC, FCC, and HCP, it has no cubic interstitial site radius. And then lastly is the fraction of a cell's volume occupied by interstitial sites. For BCC is 10.81%, and for FCC and HCP is 6.94%.
Okay, there are many manufacturing industry process based on FCC, BCC, and HCP. But today I will be show you one of example from FCC, BCC, and HCP. So okay, first for FCC, we choose aluminum manufacturing process, which is aerosol. So as you can see for the example video of aerosol manufacturing process regarding on FCC. Second, for BCC, we choose a battery lithium manufacturing industry process. So this video show you the process how make battery lithium. Okay, last but not least, for HCP, we choose a titanium element. Today, many manufacturing like aerospace industry use titanium as a primer material because it has strong and durable.